All right, so hello students. Welcome to the series of lectures on digital speech processing. So in this video, I'm going to explain about the classroom discussion topic that is short-term autocorrelation function. So let's get started. All right, so this is the lecture learning outcome. On completion of this lecture, you'll be able to illustrate the short-term autocorrelation function. So what is autocorrelation function? As we already know that, what is a correlation? So when we take the two sequences, okay, for instance, if you take the two sequences, that is x of n and then y of n, okay, so now we are going to be seeing the similarity of the two sequences. So when we take the similarity of the two sequences, then it is nothing but your autocorrelation function. Okay, so that means what we are doing here is that we are going to be taking the samples. Okay, when you take the x of n as a sequence and when you take the y of n as another sequence, and now we are going to be checking the degree of the similarity of the two sequences. So that is nothing but autocorrelation function. Okay, so when we take the first sample, so we are going to be calculating the first sample for the two sequences. When you take the x of n, for the first sample we are going to be extracting, and for the y of n, another first sample we are going to be taking, and we are multiplying with each other and taking sum up. Now we are going to be estimating what is the autocorrelation function. Okay, it is very simple. Autocorrelation, which is a cross correlation of a signal with itself. Okay, when you look into the equation which is already provided in the slide, so pi of t is equals to 1 by n. Summation starts from n equal to 0 to n minus 1 x of n and x of n plus tau, where x of n is your speed signal, for instance, and x of n plus tau, which is shifted version by a sample called tau. Okay, so it is shifted by tau times. So the maximum of the similarity occurs for the time shifting of the zero. Obviously, that also we can see when we come to the topic of this point. So another maximum should occur in theory when the time shifting of the signal corresponds to the fundamental period. Okay, so that details of that. So when it refers to the last point, so the details we can discuss about the extraction of the fundamental period with the help of this autocorrelation function. Okay, now in this video I'm going to explain about only the theory behind autocorrelation function and mathematically how we can express, and when you apply the speed signal, in what way we are going to be calculating the autocorrelation function, and after that what is the short time autocorrelation function also we will be able to see. Okay, and we have the another topic, how we can extract the fundamental period, okay, using the autocorrelation function, that is short time autocorrelation function. That also we can discuss when topic comes. Okay, all right, so these are the very important mathematical expression that you need to observe, even though we have already gone through about this. So for a deterministic signal, so the autocorrelation function, which is defined as, which is labeled by pi of k, that is the denotation, and which is equals to summation m tends to minus infinite to infinite x of m into x of m plus k. So where here the x of m is nothing but the speed signal, and x of m plus k nothing but which is shifted by k samples. Okay, autocorrelation function nothing but we are going to be checking the similarity of the same function, same sequences. Okay, and one is the same sequence, one is the sequence of x of m, and another shifted version of the same sequence, that is x of m plus. In that way, you need to understand. So for a random or the periodic signal, the autocorrelation function that is given by like this. But mostly the deterministic signal we are going to be considering, and we are applying some window techniques to it, so that we are going to be calling that as a short term or the short time autocorrelation function. Okay, and this is very important property I have mentioned here. So if x of n equal to x of n plus p, and then pi of k equal to pi of k plus p, that means what you need to understand from this is that the autocorrelation function which preserves the periodicity. Okay, that is very important property of the autocorrelation function. Okay, and whatever the point I have mentioned in the previous slide is that, so when you take k equal to 0, for instance, okay, so let me take k is equals to 0. Now you are going to be calculating what autocorrelation function. So what happens if k equal to 0? x of m is multiplied with the same sequence, that is x of m, and you're taking the sum. Okay, so this is nothing but you are going to be calculating pi of 0. So no, so this is the pi of 0. Let me write like that, and which is equals to, you'll be having summation x of m and then x of m. So that is multiplication of the same sequence. I can write x square of m. So what is sigma x square of m? Which is nothing but the energy of the signal. So that we have already seen in the previous video. So in one of the previous video, we clearly explained about what is an energy and what is the short-term energy. So this is nothing but an energy. Where what is an energy which will be having the highest peak values of the speed signal? Yes or no? Okay, but when you take a equal to 0, this is what happens. And when you take a equal to 1, which is shifted version, you are multiplying the same sequence with by one sample and two samples, three samples, and up to k samples. Okay, so that way you need to understand. All right, so coming to the short time autocorrelation function. So this is the way how we have defined. We also know that when we consider the speed signal and how we apply the window methods to it, okay, that we have already seen in the previous parameters. This is also one of the time domain parameter. Now let us discuss about this. Okay, so this is very important time domain parameter we are calling as a short time autocorrelation function. The procedure is simple and same that we have already discussed with the other parameters. When you consider the speed signal of x of m and we are going to be applying the window, normally we are applying the rectangular window for speed signal and we are taking the segments. Okay, the complete speed signals we are dividing in the slices. We are taking the segments and we are applying the parameters. Okay, so here we are going to be calculating the autocorrelation function. That is only the reason. That is only the difference we can observe when we compare with the previous parameters. All right. Now this is a mathematical expression that you can easily identify from this. So a reasonable definition for the short-term autocorrelation function Rn of k is given by summation x of m and then w of n minus m and x of m plus k and then w of n minus k minus m. We are going to be applying the rectangular window to the short segment of the speech. Okay, so procedure is very simple. We are selecting a segment of the speech by windowing technique. Usually we apply the rectangular window, and we also know what is the benefit that we will be getting when you apply the rectangular window, and you can also apply another kind of the windows also. And the second point is that compute deterministic autocorrelation of the windowed speech. Okay, so the windowed speech we are going to be computing or the calculating the short term autocorrelation function. That's all. Now, symmetry property is a very important property here. So when you replace Rn of k is equals to R, the equation, whatever that we are seeing in the first one, is modified like this. X of m into x of m minus k now. Previously, this is m plus k because we are replacing k with minus k now. And w of n minus m and w of n plus k minus m. That we are going to be seeing. Okay. And how we can define the filter of the form. The filter of the form w of k n equal to w of n into w of n plus k. Okay, so this enables us to write the short time autocorrelation function in the form. So similarly, we are going to be considering short time autocorrelation function in the form like Rn of k is equals to x of m into x of m minus k wk of n minus m. That's all. Okay, because when you define the filter of the form w of k, that is a multiplication of w of n into w of n plus k. The way how we have already seen for the autocorrelation function, the windowing technique also we are going to be taking like that expression, so that you'll be having the Rn of k like this. So the value of the w of n of k at time n for the kth lag of k sample is obtained by filtering the sequence x of n and x of n minus k with the filter with the impulse response. And you can also observe from this slide is that the block diagram. So this is a block diagram representation how we have taken the sequence of the x of n, that is a speed signal for our application, and how we are going to be calculating the Rn of k, that is an autocorrelation. Okay, so first x of n is directly we have taken to the one of the multiplication, and then another sequence that is shifted which is delayed by the k sample x of n minus k, two are multiplied, and we are applying the window technique and we will be having the Rn of k, that is the short time autocorrelation function. So this is a short-term autocorrelation function for a deterministic signal. The autocorrelation function should be like this. In the pictorial representation, you can also easily understand from this figure. These are the properties. Pi of k is even, that is pi of k equal to pi of minus k, and which is maximum at k equal to 0, that is energy, nothing but pi of 0, which is the energy or the power for the random signals, and this point also we clearly mentioned, pi of k equal to pi of k, which preserves the periodicity. And this is also very important, Rn of minus k equal to Rn of k, mathematically we can prove like this. And this is a block diagram representation for convolution y of n into h of n. And this is the segmentation of the speech, short-term segmentation we are going to be taking the L points which are used to compute that Rn of 0 and L minus k points which are equal to compute the Rn of k. That is only the difference. So this is a short-term autocorrelation function. Clearly we can see the red colors. There is a peak that can be available in the red color. So this is the fundamental period. If not, this is the twice of the fundamental period. This is thrice of the fundamental period. Okay, so much discussion we can focus on this when we want to extract the fundamental frequency with the help of the short-term autocorrelation function. Okay, so which is the time difference between the two successive peaks is nothing but the pitch of the fundamental